Hi, Tens. It's Miss Charbonneau. We're going to do a little bit of physics today. And what it's just a very quick lesson. It's all about how we use the different wavelengths of the electromagnetic spectrum for our everyday lives. So you can see a couple examples there at the bottom. But first off, let's start with the remember questions. So 5 questions, revision. First off, put the electromagnetic spectrum in order with the shortest wavelength first. Okay, so there's 7 parts of the electromagnetic spectrum. Put them in order. Which part of the electromagnetic spectrum has the most energy? What is the part of the electromagnetic spectrum that is used by water companies used to kill germs? What is the definition of ionization? And then what is the speed equation? Okay, pause the video here, answer your 5 questions, and then come back for the answers. Okay, so answers. So for the first one, gamma rays have the shortest, then X-rays, ultraviolet, visible light, infrared, microwaves, and radio waves. Now, what is the one that has the most energy? Well, that's the one that has the shortest wavelength, which is gamma rays. Then ultraviolet light is used to kill bacteria in water by wastewater companies, and that's a bit of a link back to Mr. Fisher's lesson about wastewater as well. For ionization, with a Z or with an S, is a process in which electrons in atoms absorb enough energy to break free from the atoms which hold them. And this is the reason which makes gamma, X-rays, and ultraviolet waves so dangerous to humans, is because of this ionization process. So it can cause mutations or it can cause cancers. And then 5, the wave equation. This is going to keep popping up. You're going to need it for the assessment today. Guaranteed you will have to do something like this on an exam at some point. Okay, so the wave equation is wave speed equals frequency times wavelength. Something you've just got to remember, so you need to practice it over and over and over again. Okay. All right, so what I'd like you to do is go back to lesson 2, or get this sheet from your lesson 2 notes. Now, if you did it on the computer, that's fine. Pause the video, go back and get it. But what we can do today is the notes that I'm going to go through, you can just add to the information that you've already started to collect about the electromagnetic spectrum on the sheet. Otherwise, if you didn't do it in the first place, or you don't want to go back, you can just make separate notes on what we talk about now. Okay. All right, so first off, we are going to talk about the 7 different bits of the electromagnetic spectrum and how we use it in our everyday lives. Now, there are many different uses for some of these, but I'm going to go through the ones that the exam board requires you to know for your exam. Okay, so first off, radio waves. We use it for communication and for our TV. So many of you at one point in your lives have probably been listening to a radio, using an aerial, or you use the aerial for your TV or your Freeview, and so therefore you are transmitting, or you're absorbing some of those radio waves that's in the air. Microwaves, most of us use it for cooking our food, if you've got a microwave in your kitchen. The other way that most of us use microwaves is for satellite communication. So that could be your mobile phone, that could be your satellite television. So if you've got Sky or BT, you've got a satellite dish on the side of your house, and therefore you'll be using microwaves to get communication. Infrared waves, most of us use it in our oven, or in the middle of the winter, some people have those electric heaters that you plug in that adds just that little bit more warmth. And in those cases, you're using infrared. And what's fitting for what we're doing at the moment with COVID-19, many places are now starting to take your temperature as you go in, especially like at airports and at schools, and they'll be using versions of infrared cameras or infrared thermometers. But the infrared cameras that you're probably familiar with are the ones that you often see in movies, where you can see the hot, warm body moving across the screen. They're usually in reds and yellows. Visible light, communication companies will use fiber optics to send information really long distances using light. Okay, so this is if you've got like Virgin television or internet. It's fiber optic cables that are taking that information from the main distribution center to you and your house. Ultraviolet light, okay, beyond what the sun is giving, the main use for us in our homes is in energy efficient light bulbs. We would have looked at this back in Unit 1 or Unit 2 when we were looking at energy efficiency. So the difference between a fluorescent light bulb and the energy efficient light bulbs is that it uses ultraviolet light, which means that it's using less energy overall to make that light, which is really neat. And there's a video to follow that talks about it in a little bit more detail. And then sunbeds or sun tanning beds, they'll use ultraviolet light so that you can get a nice golden brown sheen to your skin. All right, x-rays are used for diagnosing broken bones. Also, too, you can also, if you've swallowed something, the doctor may have wanted you to go get an x-ray, especially as a kid, to see where that thing is in your digestive system. And then gamma waves, again, is using for treating and diagnosing cancers. Okay. So again, this is the list. If you're foundation and higher, you need to know this list. But for foundation students, this is all you need to know about this topic. Okay. What I'd like everybody to do in a minute is you will be looking at a video, watching a 4-minute video, and that's beneficial to anybody. But then foundation students, you can go to the apply question, and then higher students, there's a little bit more work for you to do. Okay, so foundation, off you go to the apply slide, and higher, you're going to come with me to the next 3 slides. All right, so there's a little video for you guys to watch. It explains it in a little bit more detail from an expert. You can always find he does lots of different videos. If you're stuck on a topic that you haven't understood, by all means, this gentleman does a series of videos for GCSE Science. So please, by all means, access his other stuff after you've watched this one. What I want you to pay attention to when you are watching this video is the explanation on why each electromagnetic wave is suitable for each use, or each practical application. And that's what makes a difference for higher students to foundation students, is you need to explain the why. Why is it suitable? Okay, so as you're watching, make a few notes, and then compare your notes to the next 2 slides. I'm not going to go through the next 2 slides with you because that's what this gentleman does in the video. So it's just for you to check that you've gotten everything from the video that we want you to have had. Okay, so watch the video, take a look at the next 2 slides, pause where you need to, and I will meet you again on the apply question. All right, the apply question. So there's 3 questions here. So the 4 types of electromagnetic spectrum are used for communication. Okay, so between radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma waves, 4 of them are used in communication. And it's the 4 that are non-ionizing. It's the ones that aren't going to cause us any issues. Okay, so of the 4 of the 7, which is radio waves, microwaves, infrared, and visible, which one is used when a traffic signal communicates with a car driver? So when a traffic light changes, which of those 4 types of electromagnetic waves do we use to see the change? Which type of electromagnetic wave is used to communicate with a satellite in space? And then which type of electromagnetic wave is given out by a TV remote control? Okay, pause, answer those 3 questions, and then come back for the answers. All right, answers. Okay, so what light communicates with the driver and from the traffic signal? That is going to be your visible light. Microwaves are going to be used to communicate with the satellite, and it's infrared that you can find in your TV remote control. All right, now the assess questions, a little bit harder, challenging you a little bit more. Infrared and microwaves are 2 types of electromagnetic radiation. State one example of the use of each type of radiation for communication. So for infrared and for microwaves, you cannot use cooking. Cooking is not a form of communication, so we want the other type of examples that you would use infrared waves and microwaves for. B, some of the properties of infrared and microwaves are the same. State two of these properties. Again, you're thinking back to one of the first lessons that Sir did with you with the electromagnetic spectrum. And it's what two properties do they share? Number two, suggest why doctors use x-rays even though this increases the risk of cancer to a patient. So again, it's a common sense answer. It's nothing that we may have said or done in a lesson before. You're using your logic to answer this one. So why would doctors use x-rays even though there's a small possibility of you getting cancer from using it? And then number three says x-rays are used in hospitals for computed tomography, which is CT scans. Okay, so you may have heard of a CT scan before. State one other medical use for x-ray. So besides using it for a CT scan, how else do doctors use x-rays for medical reasons? Okay. And then using those reasons, whatever reason you stated, what property of an x-ray makes that suitable for your answer? So again, this is more so for the higher students to be answering, but what property of x-rays allows the medical use of x-rays to happen? Okay. Pause where you need to answer these questions and then come back to the answers. Okay, answer time. So for infrared, the type of communication that you might get is for remote controls. So we use a remote control to communicate between you and the television, or you and your Bluetooth speaker or something like that. Okay. Bluetooth would be using microwaves. Okay, so mobile phone, satellite, Wi-Fi, Bluetooth, you're using microwave communication for that. Okay, so if you said one of those, you got it right. Some of the properties for infrared, you got the same speed. They both are transverse waves. They both transfer energy. They both can be absorbed or transmitted. They can both be reflected or refracted. And they both can travel through a vacuum or through space. Okay, so if you said any two of those, you got those right. Okay, and if you didn't get those, it's a good opportunity to remember that actually, if we're talking about any electromagnetic spectrum or wave, these can also be applied to them. Okay, so all electromagnetic spectrum waves travel at the same speed. Their frequency and wavelengths may be different, but they all travel at the exact same speed. And these other properties would be true about them as well. And then two, suggest why doctors use x-rays even though this increases the risk of cancer to patients. Well, the very logical answer is that actually the benefit of being able to see what's happened to your bones outweighs any of the risk of exposure. So oftentimes, depending on what is being x-rayed, you'll have such a small, minute chance of getting cancer from it or mutating your cells from it, that actually being able to see what's going on in your body is far more beneficial than any chances of you getting x-rays. Okay. All right, number three, x-rays are used in hospitals for computed tomography CT scans. State one other medical use. Well, that is going to be detecting bone fractures, which I'm hoping 90% of you said. You may also know that you've had x-rays done when you've gone to the dentist to see if there's any dental problems in your mouth. And then another option is for treating cancer. So how do you answer the next question? What properties? Well, if you're talking about bone fractures or the dental problems, then your answer for that will be that the x-rays affect the photographic paper like light would, and that the x-ray is absorbed by the bone and transmitted through soft tissue, and that's why the bone shows up on the paper or the image. If you said that it treated cancer, then the answer that you would put down is that it's good for treating cancer because x-rays kill cancer cells. Kind of simple, isn't it? All right, so this is the end of the presentation. Thank you for listening. There is a set of assessment questions, 20 marks, in your lesson for today. So please go and do that. May I also say, please, guys, try every question. For those of you who like to be putting question marks or I don't know or random letters just so that you can get to the next question, we will be cracking down on you. So please put your best effort forward, and thank you to all of you who have been doing that all the way along. Please make sure you're reading our feedback after we have marked your work. I hope everybody's doing very well, and we will see you soon when you come into school. Thank you very much. Bye.